Hi all, welcome to our crash course session. In this session, we are going to discuss some of the most important problems, concept-based problems from the topic limits and continuity. As I will show the questions which we are going to discuss, these all are the questions that we will discuss, right? All are simple questions, but concept-based, right? All are different types of questions. This will be useful highly for JEE aspirants and those who are writing KEAM and other competitive examination. These all are our questions. Okay. Now we can go to our first question, right? So our first question is a very simple question, right? That is limit n tends to infinity. Tan x by 2 sec x. Here there is an order, right? First here is tan x by 2. And second term tan x by 2 square. And again sec x by 2. This goes on until the last term is tan x by 2 raised to n, sec x by 2 raised to n. And options are given, right? First I am going to select this first term. The first term is tan x by 2 sec x, right? Now we can write this as sin x by 2 by cos x by 2, right? Multiplied by 1 by cos x, right? So in the numerator we have sin x by 2. So we can write this as sin of x minus x by 2, right? And the denominator we have cos x by 2, cos x. Okay. Now we can use sin of a minus b formula that can be applied to the numerator. So the numerator becomes sin x cos x by 2 minus cos x sin x by 2. This divided by cos x by 2 cos x. This divided by also cos x by 2 cos x, right? Now we can cancel the common term. Here cos x by 2 and cos x by 2 will cancel. Here cos x and cos x will cancel. So this is equal to tan x minus tan x by 2. Right. Now consider the second term, right? Here is tan of angle is x by 2 square, right? Here is tan x by 2. So this is again divided by 2 is angle, right? Here sec x and sec x by 2. So we can write this term as tan x by 2 minus tan x by 2 square and so on, right? So we can write the entire function as, we can write this as limit n tends to infinity. First factor becomes tan x minus tan x by 2. And second factor we can write as tan x by 2 minus tan x by 2 square plus the third term becomes tan x by 2 square minus tan x by 2 and so on. And the last term becomes, what is the last term? Again, right? The last term as tan of x by 2 raised to n minus 1 minus tan of x by 10. Okay. Now if you look at this terms, here this tan x by 2, first factor of the second term will cancel, right? Similarly, this get cancelled. So the first term is cancelling, so this will cancel. So the remaining term becomes tan x and this last term, right? So we can write this is equal to limit n tends to infinity tan x minus tan x by 2 raised to n, right? Okay. Now we have the limit here is n in terms of n. Here tan x. This is independent of n. So we can write tan x. Right? Minus limit n tends to infinity. Tan x by 2 raised to n. So this is equal to tan x by 2 raised to infinity, right? So that is equal to tan x by 2 raised to infinity is, so this is equal to tan 0, and the value of tan 0 is, so the term remaining is only tan x, right? So the answer is, or the value of this is, so it is our correct option. Our correct option is C. I think the question is clear, right? Now look at the second question, right? We have function f of x, and they are given that is a continuous function, and a functional equation is given, right? The functional equation I'm rewriting here: f of x multiplied by f of 1 by x, that is equal to f of x plus f of 1 by x, right? This is for every x in the domain of f, right? And one condition is given, that is f of 1 is greater than 0, right? Now we want to evaluate the value of this limit x tends to 1 f of x, right? So this is a continuous function. So the value of the limit, that is same as the value of function at x is equal to f of 1, right? Since continuous means limit is existing, right? So now put x is equal to 1. So we can write this as LHS as f of 1 multiplied by f of 1. So this becomes, I'm writing this f of 1 into f of 1. That is equal to f of 1 plus f of 1, right? Or we can write f of 1 the square, that is equal to 2 times f of 1, right? Now we can take this pair to R LHS, right? So we can write f of 1 multiplied by f of 1 minus 2, that is equal to 0, right? From here, either f of 1 is equal to 0 or f of 1 is equal to 2. But this is not possible since f of 1 is greater than 0. So the value of f of 1 is 2, which is given in option number A. Okay. Now, this is our third question, right? Limit alpha tends to pi by 4 sin alpha minus cos alpha, right? That means sin pi by 4 minus cos pi by 4 by pi by 4 and pi by 4, 0 by 0 by 4. This is an all India engineering entrance examination. Right. So we can apply L Hospital's rules, right? So we can write this limit as limit alpha tends to pi by 4. Sin alpha derivative becomes cos alpha plus sin alpha divided by 1 minus 0. Now put the value of alpha is equal to pi by 4. That is cos pi by 4. Cos pi by 4 is 1 by root 2 plus sin pi by 4 1 by divided by 4. So this is equal to. So A is the correct. Now a third question, right? This is also a very easy question. A quadratic equation is given. What is our quadratic equation? Ax square plus bx plus c is equal to 0. And alpha and beta are the roots. So alpha and beta are the roots of this quadratic equation, right? So we can write sum of the root, that is alpha plus beta, that is equal to minus beta a. Alpha beta is equal to c by a. Okay, this is the information we gathered from quadratic equation. Now we want to evaluate the value of this. We can write this quadratic equation as a into x minus alpha multiplied by x. Right. This is equal to 0. Okay. So now the limit becomes limit x tends to alpha 1 minus cos of. We can write the quadratic equation as a into x minus alpha multiplied by x minus This all divided by x minus alpha the square. Right. Now we can write this as limit x tends to alpha 1 minus cos a into x minus alpha into x minus b. This divided by x minus alpha the square. Okay. So we have a standard limit, right? What was the standard limit? A standard limit is limit x tends to 0, 1 minus cos x divided by x square, right? Your angle is x and the denominator becomes x square. The standard limit, this value is 1 by 2, right? Provided this is a form 0 by 0. Okay. So I'm going to make this. Now your angle is a into x minus alpha into x minus alpha. So we have to write a square. X minus alpha square are they available in the question. So we can write x minus beta. So as to mathematically balance, we have to write here a square into x minus beta square. Okay. So the value of this limit, that is into 1 by 2 into a square into alpha minus beta the whole square. This is the value of the limit, right? Now what is alpha minus beta? You can write alpha minus beta the whole square, that is equal to alpha plus beta the whole square minus 4 alpha beta. This is minus b by a whole square minus 4c by a. Taking LCM and simplify, this becomes b square minus 4ac divided by a square. Now put the value in this equation. It will become 1 by 2 into a square into b square minus 4ac divided by a square. A square and a square get cancelled. So this is equal to b square minus 4ac by 2. Right. This option. So our correct option is C. Okay. Now our fourth question is a very good question and simple question. We want to evaluate, right, limit of this function minus limit of this function, right? This is an all India engineering entrance question 2000, right? So limit n tends to infinity 1 raised to 4 plus 2 raised to 4 plus 3 raised to 4 plus n raised to 4 divided by n raised to 5. Here is a short trick, right? The trick is here the degree of n is 4. Here it is 5. So what is the difference of degree? Difference of degree, that is equal to 1. If the difference of the degree is 1, the answer will be 1 by degree of denominator. Degree of denominator. Right. Denominator should be greater than numerator, right? And difference should be 1. Then the answer is 1 by 5. Right. Okay. If the degree, for example, limit n tends to infinity, I'm writing 1 raised to p plus 2 raised to p plus 3 raised to p n raised to p. Right. The p is an integer, positive integer, right? P is a positive integer, belongs to I plus. All divided by n raised to p plus 1. Right. So that's the difference of degree. Denominator degree is p plus 1. Numerator is denominator is highest, right? Degree is greater than 1. So the difference of degree is equal to 1. Then the value of this limit is 1 by p plus 1. That is the degree of denominator. Okay. If the degree, we have to some conclusion here. If degree difference in numerator and denominator is greater than 1, and degree of denominator is large, then the value of the limit is equal to 0. Right? Or we can write, suppose I have limit n tends to 1 cube plus 2 cube plus 3 cube, that's going on, plus n cube divided by n raised to 5, right? Now what is the difference? Here the difference is 2. Difference is 2. That's greater than 1. So the answer is equal to 0. Okay. What happens if same degree? With the same degree, 1 cube plus 2 cube plus 3 cube and to n cube. The degree of denominator is also some n cube. And limit and tends to infinity. This is same degree, right? Here it is n cube, then n cube. Then this answer becomes 0. Okay. Suppose this is n square. N square. Here it is 3, right? Then also the answer becomes infinity. Right. Okay, this is short break. Suppose in this question, we have some, the denominator I have some 6 or some constant. Then the answer of this n raised to 4, right? N raised to 4. Now what is the degree difference? Row, back, row. Right? Suppose our question is some 6 n raised to 4, right? Now here it is 4, 3. The difference is 1. Then the answer becomes 1 by 6 into the degree of denominator, that is 4. Right, so the answer becomes 1 by 24. We can use this concept over here. Now look at the degree. Here it is. Therefore, I will erase this, right? Now, here degree is 4 and 5. Denominator is highest and difference in degree, difference of degree is equal to 1. So this is 1 by the degree of denominator, 1 by 5. This minus, here it is 3, this is 5. Difference is 2, that's greater than 1. So answer is 0. So 1 by 5 is the now look at this question. It's a very simple question, right? Limit n tends to infinity, cos x by 2 multiplied by cos x by 2 square, cos x by 2 goes on cos x by 2 raised to n. Right. Now I'm writing this in the reverse order. Limit n tends to infinity, I'm writing the last term first. Cos x by 2 raised to n multiplied by cos x by 2 raised to n minus 1. This goes on. Finally, we get cos x by 4, cos x by 2, right? And we know that sin 2x, that is the value of sin 2x, that is equal to 2 sin x cos x. We are going to use this concept. So, and what I'm going to do is, I'm going to multiply the numerator and denominator by 2 times sin x by 2 raised to n. Right. We have a limit n tends to 2. So I have to divide this by 2 sin x by 2 raised to n. Okay. Now this tail we can collectively, we can use this formula and become sine x divided by 2 raised to n minus 1. Okay. This into our next term is this cosine term. Cos x by 2 raised to n minus 1 and the remaining terms. So we multiply this with 2. Right. So we have to divide by this. So this becomes 2 square into sine of x by 2 raised to n. Again, we have limit here, limit and cancel. Okay. So this term collectively becomes sine of x by 2 raised to n minus 2. Right. And the next term coming here is cos x by 2 raised to n minus 2. This goes on last term cos x by 2, right? And we have 2 raised to 2 into sine x by 2 raised to 2. Again, we can 2 added in the multiplied in the numerator. So denominator becomes 2, right? Right. And again, we have limit also here, right? Limit n tends to, right? And this goes on, goes on. And finally, what happens? It becomes limit x tends to infinity. Sine x by 2 into cos x by 2. And the denominator becomes 2 raised to n minus 1. Sine of x by 2 raised to n. Again, we multiply by numerator by 2 and denominator also. So this becomes limit, this is not x, this is n, right? N tends to infinity, sine x divided by 2 raised to n, sine of x by 2 raised to n. Now we want to evaluate the value of this. So this limit is equal to limit n tends to infinity, sine x divided by sine angle here is x by 2 raised to n. We can take this 2 here, 2 raised to n, right? I'm adding an x here. So multiplying by x, so as to balance. So what's the value of this limit? When n tends to infinity, x by 2 raised to n tends to x by 2 raised to infinity. That is x by infinity, that tends to 0. So this becomes from sine 0 by 0. So value of this limit is 1. Okay. So the answer becomes sine x, this term, and the value of this limit is 1. So we have sine x divided by x. So what is our option? Our option is D. Now, look at this question. We want to give, they are given a function tan of weightiest integer inside the weightiest integer function e square x cube minus tan of weightiest integer function inside the weightiest integer function minus e square x cube by sin cube. And the x not equal to 0. When x is equal to 0, what happens? That becomes 0 by 0, right? And f is a continuous function at x is equal to 0. We want to evaluate f of 0. That means limit x is that continuous. That is limit x tends to 0. F of us is same as f of 0. So we need only to evaluate the value of this. Okay. So we have box e square, right? What's the value of e? The value of e is approximately 2.72. And e square is approximately 7.3. So the greatest integer function of e square, that is 7.3. That is equal to 7, right? And their greatest integer function of this, that is greatest integer function minus e square, that is equal to minus 7.39. The value is equal to minus 8. Okay. So we can write this function as limit x tends to 0, tan this box is square, that become 8x cube. Not 8x cube, 8 tan 7x cube minus tan of minus 8 into x cube divided by sine cube x, right? So we know that tan of minus theta is equal to tan theta, right? Tan of minus theta is equal to minus tan theta. Okay, so this becomes plus, right? So we can write this limit as limit x tends to 0. I am making some mathematical manipulation so as to convert it to standard form. This angle is 7x cube. So the 7 and 7 will cancel. The x cube by added additionally into tan 8x cube divided by 8x cube. Okay, this 8 and 8 will cancel. So that is mathematical balance. Divided by sin x by x the whole cube. Right. Now all this equation is balanced. Right. This is x cube, here x cube, and this x cube is cancelled. Okay. So the value of this limit is 1. This limit is 1. And this limit is 1. So this becomes 7 plus 8. That is equal to 50. So the answer is 50. Okay. A is the correct option. Now we want to find at how many points this function is discontinuous. Okay. That is a function f of x that is given as 1 by log mod x. Alright? Okay. Now we can check how many points. What is the value of log mod of 1? That is equal to 0, right? And log mod minus 1. That is again log 1. That is equal to 0, right? So 1 by log 1 mod of 1 equal to 1 by 0 infinity, right? Similarly, 1 by log of mod minus 1, that is also infinity. And we know log 0, that is equal to. So the point of discontinuity is x is equal to 0, 1 minus 1. So answer is 3 point of discontinuity. Okay. Now, what is this problem? F of x is given, right? And they are given this is continuous in this interval, that is minus pi by 4, minus pi by 6, right? This angle is minus pi by 6. And this angle is pi by 6. Okay, this angle. Okay, now we want to find the value of A, this constant A, and right? So function is continuous means left hand limit that is equal to right limit. Okay. Then x is less than 0, right? Or we can say in the interval minus pi by 6 less than x less than 0. Mod sin x. This is equal to minus sin x. Okay. And in the interval 0 less than x less than pi by 6. This is the first quadrant. Mod sin x can be written as sin x. Okay. Now we can apply the image. Okay. So this is the condition. We are using. Now we can write left hand limit, that is f of 0 minus. That is equal to limit x tends to 0 minus 1. The more sin x become minus sin x. Minus sin x raised to a by minus sin x. Right. Okay. This is the form 1 raised to infinity. Okay. And we know a standard limit. Limit x tends to 0. 1 plus x all raised to 1 by x. The value of this limit is right. So we can write this as limit x tends to 0 minus 1 plus minus sin x all raised to 1 by minus. This all raised to b. the value of this limit is that is equal to e raised to a. Okay. Now we can evaluate. We can evaluate the right hand limit. That's the right hand limit. F of 0 plus, that is equal to limit x tends to 0 plus e raised to tan 2x, right? 2x, right? Okay. Divided by tan x. We can write this as limit x tends to 0 plus e raised to tan 2x divided by 2x multiplied by, this is tan 3x divided by 3x, right? So as to mathematically balance, what we have to write? We have to write 2x here and 3x. This x and x cancel, right? This is standard limit and this is also standard, right? So again, this is equal to e raised to 1 by 1 into 2 by 3. So that is equal to e raised to 2 by 3. Okay. So you evaluate left hand and right hand. Okay. Now they are saying the function is continuous, right? So we can write e raised to a. That is the value of function. That is f of 0. F of 0 is given as b. This is equal to b. Similarly, e raised to 2 by 3. That is equal to e raised to a. Right. Now compare the powers. Right. Here compare the powers. So a is equal to 3. And from here we get b is equal to e raised to a. That is e raised to a. Right. Okay. So what are these are correct option? The correct option is correct option. The option is there. That option is forgot to write the option. So the option is a is equal to 2 by 3 and b is equal to e raised to 3. The question is to find the values of a and b. Okay, and we have these are the remaining problems in this session that we have to discuss. That we will discuss in the next session. Okay, thank you.